All right, today we will be talking about identifying functions, okay? Functions are an expression or a rule that defines a relationship in math. So, in order for something to be a function, it needs to have each input is going to have one and only one output. So, for instance, my shoe size is 7. No matter what, my shoe size is 7. Okay, my foot is not going to change sizes. Okay, so it's something that's going to be true. So my shoe size is not 7 and 11. Does that make sense? So I am the input, okay, and my shoe size would be the output. Okay, so the output cannot be two different things. Okay, so for instance, your age is 12. Okay, well, you're not both 12 and 15. You are only 12. So you are the input and your age would be the output. If something said that you were 12 and 15, that would be incorrect and therefore not a function. Okay, so that's just an example. Now, I can have a shoe size of 7 and you have a shoe size of 7. We can both have the same output. Does that make sense? So two different inputs can have that same output. And we'll take a look at different ways that this can be visualized. But just so you're aware what we're talking about here. Um, Functions have each input has one and only one output. Okay. Now let's take a look at some pictures of what this might look like. So my inputs, okay, -3, 5, and 9. Well, -3 is 7, 5 is 6, 9 here, see how 9 says it's both 1 and 2? Well, if each input has one and only one output, 9 cannot be both 1 and 2. So this is not a function, okay, or NF, not a function. Okay, now for this one, 5, 10, 15, and 20. 5 is 3, 10 is 3, 15 is 3, 20 is 3. Well, each of my inputs has one and only one output. It just happens that their output happens to be the same. That's okay. That's like you and me both having the same shoe size. Okay, so that is a function. Let's take a look at a couple more. Number 3 here says 1 is -5, -2, 13, and 20. Well, if each input has one and only one output, one cannot be four different things. So this is not a function. Each one has only one output. 1 is 2, 2 is 4, 3 is 6, 4 is 8. Okay, so each one has only one output. Okay, and there are 2 there you can try on your own of that type. Now we can also take a look at tables, okay, input-output tables. These are also X and Y. Okay, you might see them like that, where your input is X and your output is Y. So my input is X here is -1. 1 is -2, 2 is -3. So each of my inputs has one and only one output. So that is a function. Okay. Now here, the input 5 happens many times and it's all different things. That means 5 is 0 and 5 and 10 and 15. That is not a function. You can also see these tables as ordered pairs. Okay, so you might see some listings of ordered pairs where you would have -4, 31. Okay, you would have -1, 31, 6, 31, and 8, 31. All right, these are the same thing. You just see as written as ordered pairs instead. Again, each of my inputs, my X values, has one and only one output. It happens they all share that same output. That's okay, as long as my input has one and only one output. This is going to be a function. 0 is 3, 1 is 5, 1 is 8. Look, my inputs happen twice. They get two different numbers. So this is not a function. Again, they could be listed as ordered pairs as well. Okay, there's two more that you can try on your own. Okay, then we can look at graphs. Okay, graphs, your input again is your x value here. Okay, so we can list ordered pairs. We would have -1, +4, -1, 4. We would have 1, 2. We would have 1, 5, 2, 1, and 3, -2. Okay, and notice 1 is both 2 and 5. Okay, that is not allowed in a function, so this is not a function. Okay, when you look at graphs like this, we can also do what is called a vertical line test. And what that means is if I draw a line through any part of the graph and it hits more than one dot, or more than one point on the line, then it would be not a function. Okay, and again, that reasoning is because 1 cannot be both 2 and 5. Okay, each input has one and only one output. Okay, all the other points are fine, but because this one spot has 2, that means not a function. Okay, so if we use our vertical line test here, vertical line through each of my points, only hits one dot, only hits one dot, only hits one dot. This would be a function. There's two more for you to try there. Okay, and then same thing on this one. We can do a vertical line here, here, here. It hits each of those only at one spot. Okay, so this would be a function. Now, if I draw a vertical line here, that wasn't very vertical. If I draw a vertical line here, it hits both here and here. So that means not a function. Okay, now some of you may be asking about this part right here. This is called exponential, where it gets really, really steep, but it is still at an angle, okay, which means it's only going to hit one time. And that is how you to determine if a relationship is a function.